Hey, eighth graders. So today we are going over energy levels again. We're still talking about this periodic table. So hopefully remote learners, you guys saw this little part right here. Remote learners, you will need to watch my video, which is happening right now. The video is coming after school, which is right now. Take the picture of this and turn it into Teams. So we're going to do some notes right now. So before you do that, all right, in class today, up here, I said something about we're going to get through the first section of section 1 of notes in the periodic table found below. Remote learners, fill out your own copy. Okay, so I will be asking for this your full PowerPoint notes later on, but we only got through section 1 today. And so what does that look like? Well, here's the PowerPoint, and then this one right here is your fill in the blank notes that you guys need to do. You can fill that out online by downloading your own copy and then saving it. And like I said, it'll probably take us a week before we get all of these notes finished. So we'll fill them out in multiple class periods. So anyways, if I get on this PowerPoint right here and I download it, we only went through about 5 or 6 slides. It's going to boot up here and boot up here. All right, but you can, let's see if I can scoot this up a little more. Anyways, okay, here we go. So our PowerPoint is up. However, it's loading still. Oh my goodness, what's going on? Okay. So we have our PowerPoint. So we get through these first couple ones, right? And you guys can read through this stuff. We've kind of talked about this, how the periodic tables are arranged. We talked about Dmitry Mendeleev. We've looked at the periodic table, and we've talked about this stuff. So go ahead and fill that stuff in. And then there's these last two. So that's as far as we've gotten. Okay, that's all we did today. Okay, now this is what you guys need to do. You just can't exit out of something. Okay, so now what we're going to do is we're going to draw our own periodic table, but we're not going to draw it with individual elements, okay? Right there, right here. Okay, so on your notebook, you need to go ahead and draw your own periodic table. So it's going to have an outline that looks something like that. So we start off with hydrogen, and that's the only element that I'm going to actually put on here. All right, and so as I come down here, my periodic table looks a little bit like this. Got helium right here. All right, so your outline of your periodic table should look something like this. All right, and we have these groups in our periodic table. And we're going to start from our left side and work our way over here to the right side. Okay, so our first one is in group 1. Okay, so our groups are our columns. Okay, and if you're in a group of like friends and things like that, you guys have things in common. So otherwise, these guys are known as groups, or you could also call these families, because families, if you're in a family with somebody else, you guys have similar characteristics. Just like all of these guys in this group or this family will have similar characteristics. These guys are actually really, what do I want to call it? Reactive. Okay, so that's one characteristic they all have in common. We actually call this first group of guys right here the alkali metals. All right. After that, we then have these guys called the alkaline earth metals. All right, so note that these guys are all metals. So alkaline is AlKaline, and then earth metals. Okay, if you guys can't read that. And then after that, we have some more metals. We call these guys right through here, this big section here. The metals take up about 3/4 of the periodic table of all of the elements. So we have our transition elements, otherwise known as transition metals. All right, so those guys all go throughout this. Transition elements, or you could also call them transition metals. Okay. Next is we have this weird staircase, and if you guys look on a periodic table, on a color-coded periodic table, they have these different groups labeled sometimes. So our next one right here, okay, it starts with boron right here, number 5 in the corner, and then it works its way down kind of like a stair step. Okay, and it's got a stair step fashion just like that. These guys are called the metalloids. And so the metalloids, they're kind of metals and they're kind of non-metals. So all over here, all of these guys are metals and they're transitioning to our non-metals. So once we get to these metalloids here, so we have boron up here, silicon, germanium, I think tin, tellurium, polonium's down here, and things like that. Those guys can tend to act like metals and non-metals, meaning we know that metals are actually pretty good conductors, right? We have iron over here, nickel, gold, copper, zinc. Some of these guys are pretty good conductors of like electricity or energy in general. As we shift over here to like the metalloids can, some of them can be known as semiconductors, meaning at low temperatures they're actually insulators. But as we heat them up, and they get to a higher temperature, these guys then become conductors, okay? But only that certain where we heat them up do they become actual conductors. So these guys can have properties of both metals and non-metals. So we don't call these guys gases over here, but we call them non-metals. All right, so let's start with group 7. So this is not the last column, second to last column. So we have our guys that we call halogens, and we spell Halogens. Those are our halogens. Okay, and then our last column here, these guys are known as the noble gases. Noble gases. And so our halogens, these are generally, yes, gases. Our noble gases, yes, they are gases. These guys belong to the bigger group, which is the nonmetals. So up above the metalloids, up above that staircase, we're talking about carbon, nitrogen, oxygen, fluorine, and neon, right? All of these guys are non-metals all through down here, okay? So, and then we have 2 guys left. We have 2 guys here. We have, remember there's this block. If you have a periodic table, there's these 2 rows below here. These guys are known as the lanthanide and our actinide series. All right. If you watch that video on the last slide of section 1, he kind of talks about the lanthanide and actinide series. And all we do is they belong here, and so we have row 6 and row 7. These guys actually belong in row 6 and row 7, and they're inserted right here, but we just pulled it out. And if you guys look, I think it's on the second or third slide of that, it shows you if we actually put the lanthanide and actinide series in here, then we have to take all the transition metals and all of these guys and shove them this way and make the periodic table really, really long. So it's just hard for us to read it and put it all on one page. So we plucked the lanthanide and actinide series out and we put them down here. So our lanthanide series is the top one. Series. And our actinide. I got my I and my E mixed up. And our lanthanide actinide series. The way to remember this is the lanthanide series starts out with lanthanium. Our actinide series starts out with actinium. All right? And then just a couple other things to add to this. And so you should have, or we're going to start talking about energy levels if you have not done that lab yet. A couple of you guys have already emailed me that lab. If you have not, make sure you email me that lab. So you'll enter your email onto that Google form, and then it sends it to you, and then you forward it to me. So if you don't get it, that means you did not put your address in correctly. All right? So please make sure you do that and get that to me. Also, these notes on your notebook, this stuff right here is due on Teams. I do have an actual Dropbox on Teams for this. You need to take a picture of it and put it on there, and it will be for a grade. All right? I was having you guys just email me those, and then that just really wasn't working out. So we're going to go ahead and make a Dropbox out of it. All right, so a couple other things. Oh, let's see. Red looks like it's popping up pretty good on my screen. So these guys, right? We call these guys going down. The halogens, the noble gases, all those guys going down in columns. These columns are known as groups, and we've kind of talked about groups, or family. You can also call these families. And so these guys all have similar characteristics going downwards, okay? As we go across our groups, so this is group 1, group 2, we skip the transition elements, all right? We start over here at boron, group 3, 4, 5, 6, 7. The 7th group are all the halogens, and our 8th group are all of our noble gases, okay? And so as we jump across these columns, and if we're talking about our electrons and energy levels here, so remember we have 2 rules about our energy levels. The first energy level, okay, so row 1 here, we have our rows now that go across like this, right? Our rows or periods they match up with our energy level. So if you're in row 1, that means you have 1 energy level. If you're in row 2, you have 2 energy levels. Row 3 has 3 energy levels, 4 has 4, 5 has 5 energy levels, 6 has 6 energy levels, and row 7 has 7 energy levels. So it is only possible for any given atom to have 7 energy levels, okay? And we know that our first energy level can only hold 2 electrons. Well, there's only 2 atoms in our first row, okay? Our second energy level, or our second row, 2 through 7, these energy levels can hold up to 8 electrons, okay? So we know that as we go down, we increase our number of energy levels. So we add energy levels as we go down, and then we know that it's about to fall asleep on me. I think 3 valence electrons, 4, 5, 6, 7, 8 valence electrons. And you guys are hearing me say valence electron. Valence just means outer. So really when we're starting to do these energy levels and we're looking at the electrons, we're looking at the electrons on the last energy level, okay? So that means if I'm looking at row 2, in this energy level for row 2, so that's lithium, has 1 electron in its outer. Right next to it, beryllium, which is 4, right? This guy has 2 electrons in its outer energy level. So we'd call those 2 valence electrons. Right here, 3 valence electrons in that second energy level, and so on and so forth. And so let's talk about really what that looks like, okay? So let's start there with lithium. So I know that if you look, you should be looking at your periodic table right now. If you look at your periodic table in row 2 and in column 1 or group 1, we have lithium, okay? If lithium is in row 2, then it must have 2 energy levels, 1, 2. All right, and we know that lithium has an atomic number of 3. So that means it has 3 protons. If it has 3 protons, then it must have 3 electrons, okay? So I know that only 2 electrons can exist in my first energy level, and then I can finally get that second or that third one out here in my outer energy level, or we would call this for lithium, its valence shell, because it's its outermost energy level right here. So there's lithium. That's how we'd fill out its electron dot diagram. And you guys have already seen that on your lab if you're going to do your lab, okay? If I wanted to do the next one next to lithium, so if I'm here with lithium in row 2 and group 1, let's jump over to row 2 and group 2. So the only thing I would do is add an electron. So this was beryllium, Be. So I have my 1, 2, 3, 4. So get it? I'm adding a second valence electron. If I want to go to boron, all right, if I want to go to boron, which is right here, 1, 2, 3, 4, 5 electrons total. There's 5 electrons total, but there's only 1, 2, 3, right, valence electrons, so on and so forth. If I want to go to carbon, carbon's right here. Again, I'll just keep going across carbon. I have 1, 2, 3, 4, 5, 6. So it has 6 electrons total, but it only has 1, 2, 3, 4, again, valence electrons. See how this is going? And so there are 8 columns. Well, how many electrons can we hold in how many electrons can a valence shell hold? It can hold up to 8. Okay, it can hold up to 8. Unless you're in that first energy level, then it can only hold up to 2. Okay, and so that's what you guys are going to be doing on that lab, is figuring out energy levels. All right. Let me see. We can do another one. Let's see. Let's do a noble gas here. Let's do argon. Argon is 18. So argon, I know it has 18 electrons, and that's total electrons, right? Not valence. Valence only means outer. So how many energy levels? Well, if I look over here at argon, argon's 1, 2, it's in the 3rd row. So how many energy levels would that be? We're adding energy levels as we go down. So it's in our 3rd energy level. It will have 3 energy levels. 1, 2, and 3. And I know that it has 18 total electrons. So let's go ahead and fill it up. If I start here on my first energy level, we know the first energy level can only hold up to 2 electrons. So 1, 2. Let's start over and fill this guy up to 8. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 here. I have 2 here. I have 10 so far. I need 18 total. So now let's jump to our outermost energy level. And so I need 8 more, right? So 1, 2, 3, 4, 5, 6, 7, 8. All right, so let's talk about something right here. We have all of these energy levels are full. Even its valence shell, right, its outermost energy level here is full. It's happy. This is why we call these guys, argon is a noble gas. All of these guys have a full valence shell. Even helium. Helium, right, has 1 energy level, but it has 2 electrons in it. Therefore, helium is happy. Okay, so actually what's going on is the halogens are 1, right? They have 7 electrons in their valence shell because they're in group 7 here. They're 1 away, so they really want to become a noble gas. So they will try to grab an electron from somewhere in the environment, maybe from another atom or something like that, gain that electron to have this noble gas electron configuration where it has 8 total electrons. Now, if it gains an electron, that does not change the element, right? If we have chlorine over here, chlorine is a halogen. If chlorine gains an electron, it's just a negatively charged, because electrons are negatively charged, right? If it gains an electron, it becomes negatively charged, chlorine. It's still chlorine, but it's negatively charged, all right? If we come over here, the alkali metals, right? Group 1, these guys, they have 1 electron in their valence shell. So they would actually rather give up an electron, lose. So if we're right here, energy level 3, so sodium, right? Sodium has 1 electron's valence shell. It would rather lose that 1 electron, and then it would lose an energy level. So it would lose that energy level because there's no more electrons in that energy level. Bounce up here to row 2, right? And it would have a noble gas electron configuration. Now, since it lost a negatively charged particle, the electron, now would be a positively charged. All right, we call these ions. And we're going to dive into that more next class period. Okay, but if you're getting confused about negatively charged, positively charged electrons, that's fine. You just need to know how to, for today, you just need to know how to properly fill up this electron diagram, okay, and these energy levels. So just to recap, as you go down our rows, you gain energy levels. As you go across these groups and columns, you gain electrons. But we are, for right now, when we're talking about energy levels and electrons, we're forgetting about the transition elements, okay? Just know that they exist and the transition elements are there. But when we're talking about electrons and things like that, don't worry about it, okay? Other than that, Please let me know if you guys need help. We did talk about possibly having a quiz next Friday. If not next Friday, then it will be after next Friday. But other than that, that's all I got for you guys. See ya.